Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Akmal Mustafa Bizul Hakim, and today I will be presenting my semester report for my research entitled Concurrent Measurement of pH and Electrical Conductivity Sensing in an IoT Framework. My main supervisor is Dr. Wan Fazlidah Hanim Allah, and my co-supervisor is Dr. Ili Shairah Abdul Halim. For the background of study, sensors are devices that produces voltage in response to what it measures. So this research focuses on potentiometric sensor, which is one category of the electrochemical sensor for ion detection. The potentiometric sensor uses FET and extended gate field effect transistor. So Fig 1 shows how an FET works. The gate of the MOSFET is detached and exposed to the target solution. We call this the sensing electrode or the sensing module, or sometimes even the sensing layer. Adding another electrode as reference, an electromotive force will be induced, which indicates that there is an ion activity and it can be evaluated and measured. So nowadays people talk about the IoT, the Internet of Things, and everyone wants to implement IoT in their system. So it is not surprised if I say that FET can also be used in IoT, same as the others IoT sensor. However, this is not without its problem. For the problem statement, we have three. The first is the interfacing circuitry for both potentiometric effect for pH measurement and conductometric effect. Conductometric to electrode cell for EC measurement is usually separated. And for multiple parameter analysis, often introduce crosstalk interference, which affect the accuracy of the measurement and produce misleading signals. Therefore, we want to design an integrated sensor module using power switching technique, comprising both potentiometric and conductometric sensing, with a reduction in undesired crosstalk interference caused by the concurrent measurement of pH and EC values. The second problem statement is the enormous data collected from the measurement will be hard to manage without proper storage and database management, and also a platform to visualize that data. So we want to design an IoT framework with Wi-Fi connectivity to configure electronic sensor data collected from the measurement to be stored in cloud server. Lastly is, since we want to have an accurate analysis, we have to maintain the data integrity throughout the measurement. However, sensor noise and environmental fluctuation can introduce uncertainties in the collected data, potentially affecting its reliability. Therefore, we have to implement data average technique to the sensor data as a microcontroller before we send it to the IoT server, so that we can maintain the data integrity of the sensing module performance. This is the literature review. So table 1 shows the summary of literature review for the circuit design, and the table 2 is for the IoT framework. So the scope for the circuit design is crosstalk, circuit model, and how to handle crosstalk. And then for the IoT framework is the microcontroller, connectivity, database, and the user interface. For the methodology, the information in the blue box is the first covers the first objective, and the second and the third objective is covered by this brown box. So the first part of this research framework focuses on the sensing circuit, which addresses the initial and integrated sensing circuit designs with isolation technique to mitigate the crosstalk interference. The sensor's performance is evaluated with a single point single analyte measurement using the existing interfacing circuitry. Following that, multiple ROICs or the interfacing circuitries are then designed to be integrated into a single circuit called the sensing module. Then the power for each circuitry will be isolated to allow power switching, ensuring only one circuit is on at any given time. Finally, the sensing module is tested for crosstalk and the results are analyzed. The second part of the research framework focuses on the setting up of the IoT framework with Wi-Fi connectivity using a microcontroller. This step involves configuring the Wi-Fi connectivity module within the microcontroller to facilitate seamless data exchange between the device and the server. The sensor's output data is averaged first with ESMA averaging technique before being sent to the server via MQTT protocols. Four essential software tools are installed, which is the MQTT broker, the data automation tool, the database, and the dashboard. Finally, the sensing module is integrated. Finally, the sensing module is integrated with the IT framework and demonstrated. Okay. This is the Gantt chart. So we have completed the proposal and the Wi-Fi connectivity in semester 1. We have also completed the data averaging technique, the cloud server configuration, some part of the circuit design, and some publication in semester 2. In semester 3, we have completed another part of the circuit design and another publication. And in semester 4, we have collected some data and fully committed to finish up writing for the thesis. This is the status of publication. I have submitted a total of 4 publications, but only 2 are accepted, which are from the IEEE Regional Symposium on Micro and Nanoelectronics RSM 2023 and the International Congress on Engineering and Technology ISO 2023. So this smoothing sensor data in the control IT framework with averages covers the third objective, and then the potentiometric field effect transistor relationship in the low power wide area network covers the first objective. So next is the status of thesis writing. I have completed most of the chapters except for the literature review. This title abstract is 100% completed. Chapter 1 is 100% completed. Chapter 2 is 1/6% completed, 60%. Chapter 3 for the methodology is also completed. Chapter 4 is completed. Chapter 5 is completed also. So my average percentage completed for my thesis writing is 82%. So my plan for the next semester is to submit the letter of intent and the thesis, and then I would like to publish the last journal regarding the crosstalk reduction with power switching technique. This is the reference used for this presentation, and with that I thank you.